Hey guys, I'm Jason Delacruz. Wanted to give you a quick demo of a cool little project I started working on a few months ago. It is a head tracker and video payload system for a UAV or RC airplane. It's controlled by this set of sensors, the Ocean Server S5000, I believe is the model. It's a set of, well, it's one magnetometer to give you your heading, and some accelerometers to get you your pitch and roll. For the purpose of the actual head tracker, I'm only using the magnetometer and the pitch. So let's take a look at what the actual video payload setup looks like. This is what the pan and tilt assembly looks like for now. I've mounted it on a couple pieces of plexiglass here that I just picked up at Home Depot, so I don't have so many parts laying around. I mounted the data modem down here. It's a MaxStream Extend 900 megahertz serial modem. I also have a power relay here, which is controlled by pulse width coming from an RC receiver, which would be the main receiver on board the airplane. Right now I have one just for testing set up here, a small receiver. The main board is right here using a RoboStix with a Atmel processor. Pan and tilt assembly, 180 degrees modified servo down here, and your tilt servo on top with a color camera. This antenna right here is just for the serial data modem. And back on this side, I have the video transmitter laying here. I believe this is 500 milliwatts. So it's pretty powerful video and audio, although I'm just using the video portion of the transmitter. This connector here is for the main power for the entire setup. It's powered off of 11.1 volts LiPo battery, kind of like those used for several RC airplanes and helicopters. This device right here brings down the voltage for some of the components, which actually run at 5 volts, but the camera and video transmitter both run at on 12 volts, so I needed to be able to have both voltage levels available. Okay, let's go ahead and check out the software to control this thing. It's all open source, by the way. It's available on GitHub. I'll put the address here on the screen when I edit the video. Let's go ahead and run this thing. Okay. So the idea is that this sensor will go mounted on your video goggles, or through some other device holding it fixed on your head, or such that it moves whenever you move your head. In order to power on the device, well, first we need to get it going here. You see that there's an arrow there that it's kind of showing the direction where my head is pointing, and of course how the servos will respond to that same motion. On the right here we have the actual embedded video window, which won't be powered on until we actually turn on the power relay, so that we can power the actual camera and the video transmitter. So let's go ahead and do that. In order to do that, I'm reading the pulse width from an RC transmitter, which is actually, well, I'm reading it from the receiver, which will be the main receiver on board the UAV. Hit one of the controls on here, the gear control. That should power on our relay here. Okay, sorry about that, guys. I just found something interesting here. It turns out that for some reason I can't use my screen capture application and have the actual embedded video screen work at the same time. There seems to be some funny conflict within the screen capture application. Anyways, you can see me there. That's actually being shown through the video, the payload video camera. I've set up my iPhone to actually show the camera in motion. Actually, we can look at it right here. There it is. There's my iPhone recording this video right now. And it's synchronized. If I turn my head to the right, or up, or down, we can look all around, see if we can. There's our battery. And there's me again. So the idea is that this sensor is just mounted on your head all the time, or on your video goggles. But you get a first-person view from within your air vehicle, and you can fly as if you were inside it, or perhaps think of any other applications for this remote-controlled camera device.